Today we're going to talk about properties of chords. So first we're going to look at chords and diameters. The diameter chord theorem states, if a circle's diameter is perpendicular to a chord, then the diameter bisects the chord and bisects the arc determined by the chord. So if MI is perpendicular to AD, as you can see that right angle mark right there, then that means that DE is congruent to EA, so that means again this length here is congruent to this length, and DI arc is congruent to IA, which would be this side, so that means that this length here, the arc, is equal to this arc length over here. So MI is a diameter, and AD is a chord. So let's go ahead and use it to answer these examples. So we want to find the measure of EB. So if I want to find EB, that is this length right here. And we can see that AC is a diameter and DB is a chord. And so we can see that they're perpendicular, which means that DE has to be congruent to EB. So these lengths are congruent, which means this is 10 for EB. And the arcs also have to be congruent, so that means that arc CB is congruent to arc CD, which is 62 degrees. Looking at the next one, so AB is the diameter and AC is the chord, and they're perpendicular, and we want to find what X is equal to. So we know that this length AE has to be congruent to EC, so 6x plus 1 has to be equal to 8x minus 5. So then we are just solving. And we get x is equal to 3. So the next thing we want to solve for is AC. So AC is, notice the measure from here all the way to here. So we're looking at that entire length of the chord. So if I figure out what AE or EC is equal to, then I can multiply it by 2. So if in this case, we know that AE is 6x plus 1, so 6 times 3 plus 1 is 18 plus 1, which gives us 19. So that's for AE. So that means AC would be 2 times 19, which gives us 38. Looking at the next question, so we want to find X, and again, BD is a diameter and CA is the chord, and for this, that means that these arcs should be congruent, so we can set those equal to solve. So CD's arc is congruent to DA's arc. So 5x plus 12 equals 20x minus 18. We're going to solve for x. So we get 30 is equal to 15x. 5 by 15, and we get x is equal to 6. Sorry, that should be, hold on. That should have been, sorry, 15. I don't know why I wrote 5. 15x, so this would be 5x here, which gives us 6. So 30 divided by 5 gives us 6 for x. Sorry about that, I don't know why I wrote 5x plus 12. All right, so now that we have that, we want arc AD's measure, so we're just plugging in 6 for x. So 20 times 6 minus 18, which gives us 102 degrees. And BC is the other arc length that we want, which is over here. So we know that CD and AD are congruent, and so we can figure out what arc CDA, the entire arc, is equal to, because that would be AD, which is 102 degrees, plus DC, which is 102 degrees. So that gives us 204 degrees. And we know that there are 360 degrees in a circle. So if we subtract that measure from 360 degrees, we end up with 156 degrees. So 360 degrees minus 204 degrees gives us 78 degrees. And that would be for CBA's measure. But of course, we're only looking for half of that. So we just need to then, or sorry, what am I doing? I already divided by 2, so 156 degrees. Sorry about that. So this is 156 degrees and then divided by 2 to get to 78. So then we take this for BC would be equal to 156 degrees divided by 2, which gives us 78 degrees. Okay, so looking at the next one, why don't you see if you can do this on your own. When you're done, you can on pause to check your work. So looking at this, we are solving for AC. So if I want to solve for AC, that's the entire length of the chord. And we're given that CE is 16, so 16 plus 16 gives us the total of 32 for our entire measure of AC. And then FC is the next distance that we want. And I think this is supposed to be F right here. It was just not marked on there, so I'll make sure to fix that on your home or on your notes. So FC is the hypotenuse. And we know that we have this triangle that's a right triangle right here. So this right triangle we have is a 16th length. This is ECF, and this is 12. So if I want to figure out FC, I know this is a right triangle. You can use the Pythagorean theorem. So 12 squared plus 16 squared equals the hypotenuse squared. So that gives us 400 is equal to R squared. So R is equal to 20. So that means we get 20 for the measure of FC. All right, so next we have the equidistant chord theorem, which states if two chords of the same circle or congruent circles are congruent, then they are equidistant from the center of the circle. So if CH is congruent to RD, so CH is this length here, and this is RD over here, then that means that this length from E to O is congruent to O to I. So let's go ahead and look at these examples. We want to solve for X in this case. So 12 plus 11 means that this length is 23, which means that AD and CD are congruent. So since AB is congruent to CD, then that means that this length here has to be equal to this length, and that length is 5, so that means X is equal to 5 in this case. Looking at the next one, we want to find the measure of AB. So this length and this length are the same, which means that CD has to be congruent to AB. So that means then that if we know CD's length is equal to 21 plus 24, which gives us 45, that means AB is also equal to a length of 45. Looking at the next one, we have to find X, and it gives us that AB is 13 plus 4x, and CD is 6x minus 5. So that means those have to be congruent. So 13 plus 4x has to be equal to 6x minus 5. And so when I solve this equation, subtract the 4x, add the 5, and divide by 2, and we get x is equal to 9. Now I want to go ahead and solve for AB. So that means that AB would be equal to 13 plus 4 times 9, which gives us 49. Looking at the next one, we're trying to solve for x. We know that AB is 7 and DC is 7. So that means that this measure and this measure have to be the same. So 7x minus 10 has to equal 3x plus 6. And so we're going to subtract the 3x. And add the 10. And so x, of course, then is equal to 4. All right, so the next one we have is chords and arcs. So the congruent chord, congruent arc theorem states, if two chords of the same circle or congruent circles are congruent, then their corresponding arcs are congruent. So what does that mean? If CH is congruent to RD, then CH arc is congruent to arc DR or RD. So that means that if these are congruent, then this arc is congruent to this arc over here. Let's go ahead and answer the questions then. So we want to find CD's arc. So if this AB is 120, that means that CD has to be the same because AB and CD are both congruent. So that means this is 120 degrees. For the next one, we see the two lines, which tells us that AB and CB length are congruent. So that means that this arc here and this arc here are congruent. And if we want to figure out what BC is, we can use the fact that we know this is 100 to solve. So we know there's 360 degrees in a circle. So let's call this X and this X over here. So X plus 100 has to be equal to 360 degrees. So 2x plus 100 equals 360 degrees. So 2x is equal to, subtract the 100 and you get 260 degrees. And divide that by 2, and x is equal to 130 degrees. So BC is equal to 130 degrees, and arc AB is also equal to 130 degrees. For the next one, if we know AB's arc is 155 degrees and CD's arc is 155 degrees, and that means that these two measures here have to be the same. So if we want to solve for AB, we need to find x. Well, AB actually we know is 32 because CD is 32, but to solve for x, we need to set them equal. So 3x plus 11 equals 32. So then subtract the 11, we get 3x is equal to 21, and divide by 3, so x is equal to 7. And why don't you go ahead and pause the video and see if you can do this next problem on your own. When you're done, you can unpause to check your. So for this one, we see that AB and DC are equal. So that means that this arc here and this arc here has to be equal. So we want to solve for x. So first thing we'll do is set those arcs equal to each other. So 31x is equal to 35x minus 16. So let's go ahead and subtract the 35. And we get negative 4x equals negative 16 divided by negative 4, and x is equal to 4. So arc AB would be 31 times 4, which gives us 124 degrees. So that means this is 124 degrees, and this arc is 124 degrees. And we want to find what arc BC right here is equal to. So if I want to find that, and I know this length here is 10 degrees, again, all of this, we know the entire circle has to add up to 136 or the 360 degrees. So that means that BC's arc is equal to 360 degrees minus 124 degrees twice, because we have arc BA and DC minus 10 degrees. So that gives us 102 degrees. And I think that was the last problem. Yep, so that is all for our lesson for today. Make sure to add these properties to your graphic organizer.